Today we're looking at finding absolute extrema of a function. Instead of absolute, you might also hear global. Just like with relative, what's another alternative to relative? Local. So just like with relative and local, same thing with absolute and global. So we're looking at absolute extrema, also known as global extrema. So on relative extrema, where do relative extrema occur?
At critical points.
At critical points. Relative extrema can only occur at critical points. Global / absolute extrema is a little bit different. On global and absolute extrema, I want what is my highest y value, what is my lowest y value. So the highest y value is going to be my absolute max. The lowest y value is going to be my absolute min. So where do you think those will occur? Or where is it possible for those to occur?
Points of inflection.
All I heard was some mumbling.
Positive and negative infinity.
No, because you're going to be on a closed interval.
Okay.
Points of inflection.
We're looking for the highest and lowest.
Highest and lowest. Highest and lowest. Endpoints is one spot, and where's the other spot? Nope.
The middle.
Same place relative extrema are located. Critical points. So, whenever you're dealing with the absolute extrema can occur at the endpoints or the critical points. That's the those are the only two places. Now you might notice that we have an interval here, so -1 to 5. Okay, and there is another theorem we need to be aware of. It's called the EVT. What do you think EVT stands for?
Extreme value.
Close.
Exponential.
Valve transmission.
The extreme value theorem. EVT stands for the extreme value theorem. Here's what the extreme value theorem says. If you're continuous on a closed interval, you're guaranteed to have a max and a min. So if I have a closed interval and I'm continuous, I'm guaranteed to be able to find an absolute max and an absolute min. Can you say the same for relative? Are you guaranteed to have a relative max and a relative min? No, I'm not. Okay? So I must be closed and I must be continuous. If I'm continuous and closed, I'm guaranteed to have an absolute max and an absolute min. That's what the extreme value term says. Alright, so we have 3 examples to work through. Alright, f of x equals 3x squared minus 24x minus 1. What do you think we need to do to get started? Derivative. So 6x minus 24. Then what?
Set it equals 0.
So that equals 0. Excuse me that. So what am I going to end up with? X equals 4. What is 4?
Critical point.
Critical point. And that is where this stops being like relative extrema. At this point, if I'm finding relative extrema, what do I do next? I do a sine line. When you're doing absolute extrema, you do not do a sine line. Okay? So what do you think's next?
Plug it in the original.
Plug it into the original. Along with
The endpoint.
the endpoints. So I need f of -1, I need f of 4, and I need f of 5. Whichever one gives me the largest number, that's my absolute max. Whichever one gives me the smallest number, that's my absolute min. So I plug in -1, that's going to be 3 plus 24 minus 1, so that gives me 26. Plug in 4. That's 3 times 16, which is 48, minus 96, minus 1, so negative 49. And then 5, so 25 times 3 is 75, 120, minus 1. So that's 45, 46, negative 46. So, what is my absolute minimum? Which is negative 49. So here's how I want my answer written. I want you to tell me what the absolute max or min is, and then I want you to tell me where it occurs. So my absolute min is negative 49, and it occurs at x equals 4. And my absolute max is 26, and it occurs at x equals negative 1. I'm glad you brought that up. If you're doing absolute extrema, your work is your justification. That is like the only one where your work is your justification. Okay? If it's relative, you've always got to talk. Absolute extrema, I don't have to talk. My work is my justification. Good question. John?
Do we just, if we had to justify, do we just say like because EBT or stuff? We don't.
Now, since my absolute minimum occurred at a critical point, what does that mean I have at 4 as well? Be more specific. There you go. I have a relative minimum. Okay. It's impossible for a relative minimum to be an absolute maximum. So if I have an absolute min or an absolute max that occurs at a critical point, that means that spot is also relative min or relative max, whatever it was. That makes sense? Okay. Impossible to have a relative min be your absolute max. Not possible. Make sense? All right, so let's see what this looks like on a graph. Just to kind of verify what it is we did. All right, somebody spit it out to me.
3x squared.
Say it again.
3x squared
3x squared
minus 24x. Minus 1.
Okay, now we are only interested in what? So how do I change that on my calculator? Menu, window settings. So we wanted it to be -1 to what?
5.
-1 to 5. Now, what do I always want you to do after you change your window?
Same
Menu, window, and zoom fit, which is A. All right. So as you see, the maximum, the highest we are, is over here at -1. So did we say our absolute max occurred at -1?
Yes.
Yes. And if you could notice, our minimum is somewhere in here, and then just after our minimum, it goes up. So that's why my absolute min is down here. Okay. Now I'm going to show you how your calculator will tell you what your minimum is. So let's go menu, let's go analyze graph, and click minimum. And what you do is you press enter on both sides of where you think your minimum is. And notice it said my minimum occurs at 4, and my minimum is -49, just like we figured out. Okay, so that's what we're doing. Next question. Alright, f of x equals 3x to the 2/3 minus 2x plus 1. My interval is negative 1 to 8. I want to find the absolute extreme. What do we do to get started? Derivative. So that would be 2x to the negative 1/3 minus 2. Alright, then what? Set it equal to 0. Let's go ahead and move it back or move it down. Alright, so 2 over x to the 1/3 minus 2. Then what?
Add 2.
No. Anytime I have a fraction plus or minus something else, what do we want to do? Common denominator. Always get a common denominator. If you don't, you're going to miss out on an answer. So if I get a common denominator, that's what I look like. Then what? Set the top and the bottom equal to 0. So if I set the top equal to 0, I end up with x to the 1/3 equals 1, which means x equals 1. Set the bottom equal to 0. I get x equals 0. Now, where did 0 come from? Denominator, so what do I have to make sure of?
It is in defined.
That it is defined back in the original. So if I put 0 back in the original, am I good to go?
Yeah.
Yes, alright. So I need f of negative 1. I need f of 0. I need f of 1. And I need f of 8. What happens if one of your critical points is not in your interval? Ignore it. Yeah, you ignore it. Alright, so plug in negative 1. Negative 1 to the 2/3. What does 2/3 want me to do with negative 1? Square it and cube root it, or do the opposite of what she said. Cube root it and square it. Either way. I usually like to do the root first if possible. Sometimes you can't do the root first. It doesn't work out, but sometimes it does. So what's the cube root of negative 1? Negative 1. Negative 1 squared. 1 and 1 times 3 gives me 3, and then plus 2, and then plus 1. So we end up with 6 there. Plug in 0. That was pretty simple. It's 1. Plug in 1. That's 3 minus 2 plus 1. So that's going to be 2. 8. What's the cube root of 8? 2 squared. 4 times 3 is 12. 8 times 2, that's 16. And then plus 1, so that gives me negative 3. So absolute minimum is?
Negative 3.
At x equals 8, absolute max is 6 at x equals negative 1. What do we notice about our max and min, absolute max and min in this case? They are both endpoints. So right now, I don't know whether or not 0 or 1 produces a relative max or relative min. I don't have enough information. I have to do a sign line. But the highest y value produced by x values between negative 1 and 8 would be, would be negative, what did I say, highest? So it would be 6, and the lowest would be negative 3. All right, last one. Alex told me before class he wanted a trig one, so I made sure I made that happen.
That's the try. Always a trig.
I guess it's better to do examples than on the quiz.
All right, so derivative. What's the derivative of cosine squared?
minus sine.
What is it?
No, it's 2 sine, right?
Negative 2 sine. Negative 2 cosine.
There we go. Remember, you gotta do chain rule there, so you gotta take care of the square first. Inside has to stay the same, and then derivative of cosine is negative sine, so that's where the negative came from. Alright, then what?
3 equals 0.
So that equals 0. As we do that, what else can we do? So cosine times negative 2 sine of x plus 1, so that'll both equal to 0. So cosine equals 0. Sine equals 1/2. So when does cosine equal 0? And when does sine equal 1/2? Pi over 6. And 5. What two quadrants is sine positive in?
Top 2.
Top 2. Alright, so I need f of 0. I need f of, which one comes next? Which one's the smallest of those 4? Pi over 6. Which one is after that? Pi over 2. 5 pi over 6. So quite a bit to plug in, so it'll be good practice. So I plug in 0. What's cosine of 0? 1. 1 squared is 1. What's sine of 0? 0. So that means f of 0 is 1. Now, I'm going to go down and do f of 2 pi right now as well. Because what do I know about 0 and 2 pi? They're the same. What's the technical word for those two angles?
No, they're co-terminal.
There you go. It took first hour like 15 minutes to come up with coterminal.
Well, I was sitting here taking my test when they were doing that lesson. So I should
Check out.
refresher. Yeah.
What is it? I don't remember what that is.
When they
Remember where
showed
you got an
that
angle, the terminal side is the same?
Yep.
So 0 and 2 pi, they're located at the same spot. And if they're located at the same spot, that means they're coterminal.
Gotcha.
And if they're coterminal, then the values are going to be the same.
Gotcha. That makes sense.
Alright, so pi over 6. Plug in pi over 6, cosine of pi over 6.
Yeah.
And if I square that,
3 over 4.
3/4. Sine of pi over 6, 1/2. So that becomes 2/4, so that turns this into 5/4. So since I did that one, I'm going to go down here and do 5 pi over 6. What's the only difference between pi over 6 and 5 pi over 6?
The signs.
The sine, which one's going to be different? The cosine's going to be different, but what am I doing with the cosine values? I'm squaring it. So what does that mean f of 5 pi over 6 is going to be? The same. So I know it's going to be the same. Alright, pi over 2, cosine of pi over 2? 0, sine of pi over 2? 1. And 3 pi over 2, cosine of 3 pi over 2? 0, sine.
Negative 1.
Negative 1, there it is. So my absolute minimum is? Negative 1. And that occurs at 3 pi over 2. My absolute max is 5 over 4. And that occurs at pi over 6 and 5 pi over 6. So what do I know? Pi over 6 and 5 pi over 6. What else can I label them as? Relative maximums. And what can I label negative 1 as? relative minimum. So in this case, the absolute extrema, all of them occurred at critical points. Okay, we've also had one where the absolute extrema was just at the endpoints, and we've also had one where one of them was at the critical point, one of them was at the endpoint. So there's a mixture of all those. So, what does the EVT say?
Functions
It's on
within the
closed
minimum
interval
or
continuous, you're
continuous.
guaranteed to have continuous.
So if I have a function that is continuous and it's on a closed interval, I'm guaranteed to have an absolute max and an absolute min. All right. So we take the derivative, we find our critical points, and then we find the y values that go with the critical points and the endpoints. Whichever number is the smallest, whichever y value is the smallest, that's my minimum. Whichever y value is the largest, that's my maximum. There it is. Here's another